how precise this measurement is. Now, the comparison graph that you see over here on this is a comparison an industrial grade FTIR analyzer and an industrial grade NDIR analyzer. You can see sensitivity is far better than some of the conventional analyzers that you have. So this enables us to minimize the calibration required for such applications. In fact, calibration frequency is probably once, or you can just run a value and just the readings are all right. If it is all right, then you don't really have to do any calibration. If you observe that there is some slight drift, you may want to do a calibration. But then compared to calibrations that are done on a daily basis or a weekly basis, this technology allows you to use your resources elsewhere. Another big advantage of using a laser-based solution is that you may have process variations and you may have some background gases that kind of vary a lot, affecting the absorption for the component of interest. But what we using our laser analyzers, what we can demonstrate is that even if there is a very high level variation in the background gas, it does not really affect the component of interest that we want to measure. So for example, if you look at this graph, there is change in the methane concentration in the background. You can see that the methane concentration is keeping on increasing, but the nitrous oxide peak in the center is not changed. So this does not cloud the detector, or it does not obstruct the detector in any way. Another important aspect when we of selecting this analyzer is that when a customer requests us to give us a proposal for an analyzer for, say for example, the measurement of SOx, NOx, CO, and O2 in a flue gas, what we do is that we normally ask for a process gas composition, complete gas composition, based on the minimum and the maximum ranges given by the customer. We do a theoretical calculation and we prepare something called as a spectral fit data. Now this database is part of the software that is integrated into the analyzer. Now what happens is that when you connect the analyzer to the actual process, it compares the data between the spectral fit data and the actually measured data to ensure that you are getting a precise reading, you are getting a reading that is more repeatable and linear over the range that has been selected. So this is something which goes through an extensive process in our factory in UK. So another the important fact is that just like in a gas chromatograph, we are not measuring the height of the peak, we are measuring the area under the peak. So that gives us more linear and repeatable results. So this also helps us in eliminating cross interference data. So this is one technique which we use all the time. Talking about some key applications that can be targeted using a quantum cascade laser, is that we have identified about 4 applications, but it is not limited to because of the technology. It's just that we have worked out and have proven results on some of the applications that I'm going to talk about. The primary application is in ethylene production. In an ethylene plant, of course, you have got the hot ends where you have all the tracking and everything, and then you have the cold ends where you would use the fractionators and you would have acetylene converters. So there are some critical measurements which are typically done with a gas chromatograph or an infrared analyzer. But with a gas chromatograph, what happens is that you need to have utilities like carrier gases. You may have to purge the analyzer to make it suitable for the area classification. But in our case, we have got these laser analyzers that are certified, hazardous area certified for zone 1. We have it for zone 2. And the best part of it is if you look at the table, the limit of detection is actually quite low, which is very much required, especially for this purity measurements. And also, during custody transfer for ethylene, you may want to have these kind of measurements. So you can measure methane, acetylene, methane, CO2, CO. These are some of the impurities that that you would see. And then additionally, if you want to have these measurements like ammonia, water, and methylone, it can also be done. The advantage is that you don't really need to have multiple analyzers. As I said earlier, the quantum cascade laser can have the capability of doing up to 12 measurements using a single gas analyzer. Okay. The next application is basically ammonia injection, normally to reduce the NOx concentration in the stack. There is a process of ammonia injection that needs to be done. So in that case, you may have to measure the concentration of NOx upstream and downstream of the reactor. So if you look at the table, the QCL laser analyzer is actually able to detect NO and NO2 individually instead of having to use an external converter to get a total NOx value. So this is actually quite a useful tool, because normally in a stack emission you would have very low levels of NO2 in comparison to the nitric oxide levels. So the same goes with the downstream measurements. So you can see that the limit of detection is actually quite good in the low ppm levels. The ranges are indicative. We can go at lower levels. We can in fact go at higher levels as well. The next application is basically purity of hydrogen and nitrogen. As you know, we have to use either an IR analyzer or a gas chromatograph for such kind of measurements. It requires a lot of utilities. With NDIR analyzers, you may have to perform zero calibration almost every day. But using a QCL analyzer, you would be able to reduce that frequency of calibration by quite a bit. In fact, if you look at such measurements, the readings can be stable for over a year without any kind of calibration. So this is something which we have demonstrated, and as you can see, we have really low levels of measurements. Last but not the least, emission monitoring systems. Of course, it is becoming a norm that you may have to install emission monitoring, continuous emission monitoring systems everywhere at all pollution sources. Now, the advantage of using a quantum cascade laser is that you don't really have to remove the moisture while doing the measurement. You can actually do a hot wet measurement, because we have a provision of providing a heated cell which can be kept heated to about 190 degrees C, and you can measure up to 12 components, 12 gases in a split second. You know, it's the reading of the analyzer would be about 1 second refresh time. So it's very quick, and you don't really have to frequently calibrate it. We have done RATA testing in the US at a refinery, and we have seen that the readings have been stable for over a period of 50 days. So the bottom line is that the QCL TDL hybrid analyzers are going to be the new benchmark for continuous gas analysis. Thank you very much.
Now, from this innovation plus presentation for Mr. Khalid Nadim, he is from Sator Analyzer Supervisor, and he will give some innovation in analytical technology.
Alhamdulillahi Rabbil Alameen, wassalatu wassalamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Assalamu alaikum, and good morning and good afternoon. I think I am the last person between you and the lunch, so don't blame me. I came with a mindset here in the morning, and looking at the morning session and the session which is going on right now, we have nearly 600 analyzer installed Sato, Saudi Aramco Total, refining and petrochemical company. You can easily call it Sato. I make my mind to just change at least half of them. I wish Sato could have started just now, next year. But what I'm going to present to you, the correlation and the validation studies, I think even with the replacement of my old analyzers, with the solar powered Wi-Fi connections, and whatever new technologies, the innovative approaches we have in it, still I have to stay with my own problem and issues and my approach while validating the analyzers. I will try to take not that much time. Looking at the first slide, all the companies, regardless they are producing noodles or petrochemical or refining units, the main targets are to have the quality and the production. To achieve that, there are many sections and departments behind that: operation, process, scheduling, quality control, of course, on-stream analyzer, commonly known as online analyzer. In Sato, we call them on-stream analyzer. Not but the least HR sitting somewhere in the backyard. So they all support each other to get this profitability and production to be achieved and done. We have in practice two kind of organizational setups. Either the QC labs can work independently and on-stream analyzer can work with maintenance independently. There are certain advantages, disadvantages as well in both cases. Whereas in Sato, we have joined together the quality control along with the on-stream analyzer together under one umbrella, one command and control. Of course, in a separate entity, while working with maintenance, you have more access to the maintenance logistic supports like electrical instruments, HVAC, and so on, under one notification and under one work order, which we are facing problem under this one command and control. But anyway, it's working fine with us. Someone can assume that since it is under one umbrella, under one command and control, the results can be compromised. And I can tell you, if it happens, that will be a total mess up. I work in both type of setups personally and found that while working together with quality control lab and on-stream analyzer under one umbrella, it's more responsible, more ownership, and more difficult. Because you have to raise a single voice without any compromise on the quality and high heat, giving high throughput and the productions. It's really difficult. To maintain that, we need to have a continuous correlation and validation of on-stream analyzers with the lab, with the primary tests, standards, continuous practice to be implemented and monitored. That's the main task which I'm going to present it here. And what we have developed, what we have. Of course, when we are working together, we can reduce the number of samples, which can help a lot to the plant, to lab, getting rid of many hazards,